Hey guys, this is Ms. Van Tassel. In this lesson, we're going to be looking at adding and subtracting rational expressions. And so our first step whenever we're adding and subtracting rational expressions is to write the restrictions. So we always start off with that. Our second step, so just like when we're adding fractions, we need to find a common denominator if they don't already have a common denominator. Once we find what the common denominator would be, then we need to multiply the numerator and the denominator to give us that common denominator. And then we just add or subtract the top. So we add or subtract the numerator and we keep the denominator. And so this video is going to really be a lot of me just showing different examples. I think out of all of the different operations with rational expressions, I think adding and subtracting seems to be the most challenging for students because of the common denominator aspect. And so I think just hopefully seeing it over and over in different types of examples will hopefully help you. So our first example, we have 7 over 6x plus 5 over 8x. And so you notice that I don't have a common denominator. They both do have x. But their numbers aren't the same. And so when I'm looking for a common denominator just with the numbers, I always try to pick my biggest number, so 8. And then I just list the multiples of 8 until I get something that is also a multiple of 6. So after 8 would come 16, and 6 does not go into 16, so I'm going to keep going. Then 24, and 6 does go into 24, so 24 is going to be my common number. And so they already have x in common, so I don't have to multiply anything there. So to get 24, I would need to multiply the 6 by 4. However, I can't just multiply to the denominator because then I'm changing the value of the fraction. So I also have to multiply to the numerator. And so the reason why this works is because 4 divided by 4 is really just the same thing as 1. So I'm really just multiplying my fraction by 1. I'm not changing the value at all. And then I'm going to do the same thing to my other fraction, except I'm not going to multiply by 4. I'm going to multiply by whatever is going to give me 24. And so 8 times 3 is 24. So I'm going to multiply this one by 3 over 3. So from here, 4 times 7, we get 28 over 24x plus 5 times 3 is 15 over 24x. And now I have a common denominator. So that is going to go on the bottom, and then I'm just going to add 28 plus 15. So 43 over 24x. And I am done with that problem. Well, it does get, a little bit more complicated than that. And so for this problem, I don't think I listed my restrictions. I didn't. Well, I'll do that this time. So I want to make sure that I list my restrictions. If they're not already listed for you. So I see that I know I can't have 0 on the bottom of my fraction. I went over that in the first 2 lessons for this unit. So if you are having trouble with that, you can go back and watch those videos. But this is 4 times x squared. And so what would make that 0 would be if x was 0. So I know that x cannot equal 0. That is a restriction because I can't have 0 on the bottom of my fraction. And then if I look at my other fraction, still if x is 0, 0 times anything is 0. So I already have it once. I don't have to list it again, but I do have to list it for y. So in this case, y also, I did not mean to do a different color, y also cannot equal 0. Okay, so now I'm going to try to find a common denominator. So I'm going to start with the numbers. I'm looking for a number that 6 and 4 both go into. So I'm going to start with 6. No, they don't both go into 6. So then I'm going to go to my next multiple of 6, which is 12. And 4 is a multiple. I said that backwards. 12 is a multiple of 4, so 12 is going to be my common number. And so to turn 4 into 12, I'm going to have to multiply by 3 on the bottom. And remember, I can't just multiply the bottom. I also have to multiply to the top to make sure that I don't change the value. And then also on this side, I need to multiply by 2. So 6 times 2 is 12 as well. All right, so that takes care of the number piece of it. Now I'm going to look at my variables. So I have an x squared here in this first fraction, and I have an x in the second fraction. And so I want them to be the same, and we're always going to get the same by multiplying. So I'm going to leave this fraction alone since it's the bigger one. But I'm going to multiply this fraction. So I need to multiply by an x to get an x squared. And again, what I do to the bottom, I also have to do to the top. And then also in the second fraction, I have a y squared. And so I also need a y squared on this side. Since there are no y's already, I have to multiply by the whole y squared on the bottom and on the top. And so I kind of just go like piece by piece. And I'm going to multiply those to my fractions. So I get 3y squared over 12x squared y squared plus 10x over 12x squared y squared. And now I can just add the top. I always like to put my variables alphabetically, so I'm actually going to put the 10x first. So then this is 10x plus 3y squared over 12x squared y squared. And we are done. Okay, so for this problem, this is a good example of the types of problems that I really see students struggle with. For some reason, whenever there's just a variable here, they tend to just get mixed up. And so we're going to go through this. I'm going to start with my restrictions. So my restrictions for this first fraction are just that a cannot equal 0. And then for my second fraction, 5 minus 5 is 0, so a cannot equal 5. Or you could just write it, let me fix that, with a comma and a 5. There we go. Okay, so the biggest mistake that I see is I see students who want to subtract 5 to make it a common denominator, but you can only make a common denominator by multiplying, not by adding or subtracting. So instead, I am looking at a minus 5 as a factor altogether, and maybe if you put parentheses around it, it will help you see it. And then I have a as a factor. And so I have an a, but I'm missing the a minus 5, so I'm going to multiply the whole a minus 5. And I'm also going to do it to the top. And then on the other side, I'm missing just the a, so I'm going to multiply just the a, and what I do to the bottom, I have to do to the top. All right, and so now I'm going to distribute my 2. So I have 2a minus 10 over a times a minus 5. I just keep the bottom factored, but I distribute the top. And the reason why is because maybe later on I can simplify further, and it's just easier if the bottom is already factored. I'm going to change this to a plus, and I'm going to move the minus to the top of the fraction. So you can either move the minus to the top or to the bottom, but we don't want to move it to the bottom because we already made a common denominator. And so if I move it to the bottom, it's going to mess things up. So this is going to be a negative 3a over a times a minus 5. And so then now that I have a common denominator, I'm just going to add the top. So I have 2a minus 10 minus 3a over a times a minus 5. And then my last step is just to simplify the top. So I'm going to combine 2a and negative 3a. And so that gives me negative a and then minus 10 over a times a minus 5. And that's it. We are done. All right, so let's go to our next example. I went too far. There we go. All right, so for this next example, I have 5 over c plus 2 plus 6 over c minus 3. So like I said, sometimes it's just easier to see it when you have parentheses around your binomial. And so you can see that this factor, it's missing the c minus 3, and this fraction is missing the c plus 2. So I'm going to multiply the first one by c minus 3, and then the second one by c plus 2. I'm going to distribute my 5. So 5c minus 15 over c minus 3 times c plus 2. And then plus, distribute my 6. So 6c plus 12 over c minus 3 times c plus 2. Now I'm just going to add the top. So 5c minus 15 plus 6c plus 12 over c minus 3 times c plus 2. Oh, you know what I forgot? Our restriction. So let me just go back. And so a negative 2 would make that a 0 on the bottom, and a 3 would make that a 0 on the bottom. Okay, so now I'm going to keep going. I'm going to combine my like terms. So 5c and 6c is 11c. Negative 15 and a positive 12 is negative 3 over c minus 3 and c plus 2. Now, just because you see a c minus 3 here and a c minus 3 here doesn't mean you can cross these out, because that 11 is in the front. So it's not c minus 3, it's 11c minus 3. The whole thing is a factor. So you cannot cross these out. They're not the same. And it is simplified. Okay, so this one I want to talk about specifically. I see a lot of students that struggle when there is a minus in the middle. And so for this particular problem, I already have a common denominator, which is really nice. However, this is where students tend to make their mistakes. So I'm actually going to rewrite this as 5x minus 1 over x plus 8 plus, I'm going to bring my minus up to the top, but then I have to put this in parentheses because it's minus the whole thing. So you want to make sure that you're grouping it as the whole thing. Okay, and so from here, just to make this problem a little bit simpler, I'm going to distribute my negative, which is, remember, just like there being a negative 1 in the front. So now I have, oh, I forgot my restrictions again. Oh, man. So x cannot equal negative 8 because I would have a 0 on the bottom. This is the same thing, so I don't have to write it twice, so I only have one restriction this time. Let me go back to my simplifying. So 5x minus 1 over x plus 8 plus negative 3x minus 4 over x plus 8. And I'm just going to add the top, so 5x minus 1 plus negative 3x, or just minus 3x minus 4 over x plus 8. And then 5x minus 3x is 2x. Negative 1 and negative 4 is negative 5 over x plus 8. All right, I hope that this helped. If not, just please reach out to me. I'm here to help you, so don't be afraid. I would rather help you than have you not ask, okay? It's my job to help you, so let me help you. I hope you guys have a good day and you're staying safe.